Right, I have no idea if this is even working now. The stream. Okay, I've had to be doing all sorts of bits and bobs. I've got my lunch as well, so you have to forgive me when I'm eating. But on the right hand side is a run of this standard Ackermann. And we got to Ackermann 4.1 and it crashed. Don't worry about it crashing. I know why it crashed. It's not my code. It's the nature of the function makes it crash. But essentially, it's so recursive it runs out of stack space to do anything. So the left-hand side was my special version, this version, which was meant to save time. And what actually happens is that it causes a hell of a lot of trouble. So what I'm going to do is I'm removing the M reference from this. We don't need an M reference in any of this. We can just have N reference. So empty, find it, store it. Okay. So now we have a list of N's to results. So what we need is an M to hold them. Well, what we're going to have to hold them is another map. And basically, we're going to have a map of integers to result lists. Just here. So that's a results map. And just to make sure that everything in the function can see it, we go back down here. And just make sure that we have that. We can exit this one just to give us more space. And I can finally have a drink of coffee. Wow. So now, this is all staying the same. We still want to look it up or in place something. And basically, here, we want to use the contains key. So if we go back here, yeah. So we want to check if it exists, which is find again. Finds the element with the specific key. So now here, when we come to, sorry, the mouse is crazy. When we come through the inner list, we can just go auto and then found result equals, and then this is results map.find M. So we're looking for that M result, and then if found result not equal to results map.end, we know we got something. Otherwise, we have to place it into the map. So otherwise, it is results map.insert make pair M and then result, where result is actually the result list. Result list, result, and it's empty. It's just an empty result list right now. In fact, I probably don't need those. So we're inserting that result list into there. Now, all this is going on the heap, I believe. We aren't putting any data out there into extended memory. So we'll see what it says. Yeah, yeah, this is working. Hi, hello. Okay, so that's that replacement for all of that. Okay. In fact, no, sorry, I'm confused. We don't need any of that. Return found equals true, and then R equals found result. That's not even true, is it? From the inside now, so auto inner found result equals result found result dot. It's actually found result second dot find n, and if inner found result not equal to found result second dot end, then found true not equals true, and then the dereference result equals inner found result second. Okay, so we're searching in the outer group and then searching in the inner group just to find what we want to do. That's lookup. Now, if lookup is false, then we need to insert a result. Okay, so we'll do that now. Insert result, const int m, const int n, const int r. So this is a result, and we will create result list r new result, and then we'll go new result dot insert make pair nr, and then we'll go result map dot insert make pair m new result. That's pretty much all we need to do for there. So here now, this gets a lot simpler. We go if look up mn and result. Sorry, if not. So if we didn't find it, then we know we need to in fact, we don't need to do any of that. So we can look up this value. If it doesn't already contain it, we're looking it up. So that is an additional search. We might have to come back and look at that later. We might not want to do that search there. But for now, we'll look it up. And if we don't find it, then L result equals n plus 1, I believe, which I'll check in a second. And then we need to insert result mn L result. So we're going to add it to our list of things that we're doing. Why is that into there? Okay. So that's m equals nothing. Now this one, the result equals this. And we already know we didn't find it. But hopefully this then inserts there. So do we look it up again? So we look it up. If we didn't find it, then we create it. That's fine. And the final one, the same two pieces. Right, let's see if we can now build that. All sorts of problems. First problem is in Ackermann lookup, which is this one. No member second dot end. Yeah, it's because I'm overthinking this. Result list doesn't need to be that anymore. We can just say using result list equals map int. So a result list is just a list of integers and we're mapping them to an integer. Try that now. It wasn't clear what I did. Look up 59. Result found second. Structured pair constant int has no member named second. I thought it did. So results map result. So this is not a result list. This is a auto to make pair. So we insert so result map insert make pair m of make pair n r. So that's inserting Ackermann 49 in a result. So in a found result dot second is not found. Is that better? That's better. Result map dot insert not declared in this. So that's results map node candidate provider template argument education substitute failed insert. Let's just do auto x equals make pair n r x. No idea why that's so upset. Pair type name. Is that better? Can't convert int to type int pointer. It's because they're const references. To be honest, these can be constants. This is where I need a better editor, a better IDE. fact, it can be F permissive. Results might have gone outside. It's only a warning now. Don't like doing that, but it's only a warning. Insert result without object. Static. Error, conflicting declaration, map, std map, int. Const int, standard std constant results map. I shouldn't need those anymore because they should all be const int. Let's just do that. Do that. Conflicting still. Why is that conflicting? Is it this one actually? Still don't like those warnings. Still don't like them. Failed. No name type in structure. Enable if. Substitute definitions. So in stuff in Americans from in. No matching call, std map, constant int. So that's in insert result. Make pair x. Make parent. So, why won't it let me insert a map element in a map element? Is it because it's not actually a result list? So that's better. There you go, no errors. The problem there was the insertion in each one. Hello, viewer. That's still quicker. Still a lot quicker. So that middle one will segmentation fault soon. So the other thing we can do with this is make it a tetrarchy, but I don't want to do that yet. Definitely don't want to do it. Hello viewer. Want some sausage roll? Have you got any ideas about this shit? That one crashed. That did what I expected. That one still hasn't found Ackermann. Still hasn't found Ackermann 4.1. So really boringly, I need to output more information. Oh, I know what I've done. No, okay, that's okay. I'm always inserting a new. That's the mistake. So we want to look up the outer, then look up the inner. So we only want to create a new map if we don't find a candidate map. Otherwise, we do want to use the map we're at or insert a result into it. So we found the outer. Found outer. Insert. Make pair. We couldn't find an outer, so that's why we do a new list. Otherwise, we want to find the inner. So, found outer, second of insert, make pair, N and R. That might be better. Yeah. So that's the calculation actually going on. I mean, we're into the hundreds. Which IDE am I using? Hello, I'm using gedit, and I'm just using the command line. There is no IDE, but I'm running it in the i3 Windows Manager just to help. So this is all command line. This is just a text editor. This could be any text editor. In fact, I don't like this text editor very much. This is just gedit, which is crap. So I'm into the thousands, half thousands, 1200s, 1500s. That's why we're taking on. So we're getting into n's and m's of 1. I want to actually just, there we go. I want to actually just store. So there you go. There's a lookup, and these are lookups. It doesn't get any more than that on. So they're lookups that fail. So I want to go else. do I want to calculate these at this point? So that's a not found, and just there is the same thing. See, this is why I could do with a proper IDE, because I am just struggling with this. Yeah, there are all the not founds. You can see them coming up now. We can there you go. So you can see it calculating now. It finds the inners. These are inners. So whenever we see found inner, they're pre-calculated. They're already calculated. They're basically going to be coming in here and giving us the result quicker. So they're the time savers. The ones that are shorter are the ones that are wasting our time. And we are wasting a lot of time there. So the question I have in the long run is, how many Ackermanns do I store the result for to make it worthwhile bothering to store results? If I'm only doing, oh, excuse me, if I can just mute this. Bear with me, Frecken Sen. I need to go and move the car for the wife, but I will mute this. I may or may not be back based on what she wants me to do, because she's a very demanding wife. Well, it's still running. The question is, how much time is that saving? So I'm going to kill that, and I'm going to change some of this. What we're going to do is look up an Ackermann. If we don't find it, we calculate it. So if not, look up mn the result, then calculate it. Okay. Spot declaration. There we go. So that's just going from those. So let's also sleep. Helps if you rebuild it. Sleep. Well, why is sleep not found? Let's do a standard thread sleep. Well, that's a bit of a mouthful. We use chrono and thread. std this thread. Yes, Doc. Yes, Doc. Sausage roll. Yeah.
What are you doing now?
I'm broadcasting to Sylvan. Yeah. Dash LP thread. So those were not found, and we're calculating them. So we're adding 2 each time there. Why is it saying look up twice? There you go. So that's how it's working. So all these lookups are Ackermann 2.2. All those lookups are Ackermann 2.3, 2.4, 2.5. And it had to calculate them. That was one that was looked up. So that was all completely looked up. And then we get into it there. So it is saving time, just not the time I wanted it to save. Okay. So I'm going to try and kill it just there. I'm going to make it redirect to an output text. I'm going to wait a few minutes. Hello, viewer. Okay. Now we're going to open that. So there's what it thinks it's doing. So lookup 00 not found. Then it looks it up again. I don't want to look up again. But that's what the code does, isn't it? We go in here and look it up again. So we can take that out of there. If we already looked it up, we know that's going to calculate. We only look up then for secondaries. We see out n equals 0. Calculate. And here we do see out n not equal to 0. Calculate. So now we're only doing that one lookup instead of two whenever we calculate. So there are 3 lookups there because we didn't n0 calculate. Let me go down here. There we go. So we can see these are single calculations. I could probably pre-calculate all of those. Fine, let's do that. Let's not do an inner loop. Let's do just an outer loop. And let's pre-calculate. I don't know. Should we do 65, 535, 534 of them? And just do Ackermann pinch this, can't I? Stick it there. And we have no calculator in this section. And that is how we're going to do that. So that is the pre-calculate complete. Rank 0 pre-calc complete. Look up. It was 0 0 M. So that's the pre-calc. We've calculated 65534 items. Yeah? Not yet.
Any of them?
None of them. I was letting them cool down. So there's the first thing we haven't found. Look. All the rank 1 stuff. So could we then pre-calculate in n equals naught, n smaller than 65534 plus n, and we'll do one and m, 1 and m. Right, while this is running, we'll play an ad. Okay, not happy with that. There's too much information coming out of this stuff. What I'm going to do is no. Oh, dear me. Don't know if my network attack storage is going to be online. There we go. Let's look if I can connect to. Can I connect to there? Something went wrong. Okay, I can get to the EX Silver. So EX Silver is online, which is my NAS SMB stroke eSelnet/EX Silver. It's anonymous. Okay, there's actually Ackermann stuff already on here. I didn't know about that. So new folder, alt Ackermann, and another one, home. Copy in there. That should be both those done. Let's shut this virtual machine down. And what I want to do is go into another virtual machine. Machine not found on H drive. Browse virtual machine. Enter it in here now. Code disks. This is what happens when you change some bits and bobs. Yeah. So you are. Let's find code disks. Hard drive, yes. SCSI, yes. Use an existing disk, which is there. Code disk. This is the Steam drive. Remove. Add. Hard drive. SCSI. Existing. File name. Steam drive. 64-bit Windows machine. I can give him full processor, but yeah, okay, whatever. I moved it from the H drive to the S drive. I'm hoping this machine doesn't need about 1 billion updates. It's not been on since I moved it from one drive to the other. Yeah? When he's cooled down a bit. Not really, no. Well, it didn't work, did it? Alt Ackermann, paste it in here. Okay, here is Alt Ackermann, and we've got Visual Studio 2013. This takes forever. Why is this taking forever? Oh, go away. I've got a load of crap starting. I need to run CC Cleaner on this virtual machine. Anyway, file. C++. Empty project. Browse. Desktop. Alt Ackermann. C++. Select folder. Alt Ackermann. Have an empty project. Yep. Source file. Add. Existing item. Main. Okie dokie. Just want to see if you can see that. So now tidy this up. And we want to add constable verbose false if verbose so we're only going to output this information if we're in verbose mode. So that's the lookup fixed a little bit. So we go through the outer find. Hello viewer. We go through the inner find, we set the result, and we're out. If we want to insert, we'll do the same. I'm going to sneeze. Excuse me. And we do this if verbose insert result adding new list. So we know what we're doing there, and then here if verbose cout insert result into existing list found outer first. So we can just see which one it's doing at which time. Bye bye viewer. So Ackermann now is doing this, and constable verbose if verbose calculating and here we do the same. If verbose calls verbose, that calls verbose. So we're passing the verbose value down the tree. Look up verbose, Ackermann, verbose, look up verbose, Ackermann, verbose. I don't know why that doesn't support the standard thread, but we'll look that up later. That's generally why I don't use Visual Studio very often, but hey ho. Sorry about that, I just go and check the docs. There we go. Right. So that's running like that. It's adding all the current stuff. So we're at 800, etc, etc, etc. So let's not verbose these two calls. Let's just verbose those, so we'll skip past them quicker. That's the axe. So we're at 5,000, whatever. If just output every thousandth. There we go. So we saw that go a lot quicker, and we'll do the same here. We'll not output them if n. Let's count it every thousandth, and let's do a not equal n. So this is if verbose so that's 1,000 rank 1s. Took a lot longer than 1,000 rank 0s. So we are getting through them now. It is able to calculate them. So I need to time that somehow. What I need to time them is chrono time elapsed. In fact, I've got this reference somewhere already. Hang on. Duration, chrono duration. What did I say? Stack overflow. So we've overflowed the stack again. Cut ties with parent. Iterator debug level 2. Iterator list corrupted. Debug. Where's the core stack? So that's a lookup. So we're crashing on this, and its size is 1, and it's looking up 65535. So okay. It's an interesting relationship in that the n is 1 less than the results in the rank 0. So that's that code there. Every time. Okay. I'm done for a minute. I'm going to go and clip a poodle. Bye bye.